Hello, grade 10 mathematics students. Welcome back to lesson number 1, part number 4. So let's discuss a few more examples from the last part of the video where we discussed how you graph a line when you give an equation. But what happens if you're given something that is not in a slope-intercept form? So if you have something in the standard form, so the standard form of a linear equation. So standard form is defined like this: ax plus by plus c is equal to 0. How can we graph that without knowing the other form that we're used to, which is the y equal mx plus b? So literally, if you're given something of this form, we can literally transform this. I think we did discuss this in the first part of the video, where you have to change this into, so let me just say that again here. So if you're given something of the form ax plus b, ax plus by plus c equals 0, we literally just have to solve for y. Let's solve for y. Finished. Solve for y in this problem, and you're done with it. So if you solve for y, just keep by on this side, and then move the other letters over. So this is going to be ax. Whenever you move a positive number over the equal sign, it just changes the sign to a negative, and then this is going to be a c. I want to solve for b in this case. Go ahead and divide both sides by b. So this cancel with this. So our y here is negative a over b, x minus u over b. And notice that if you compare this with this form that we know, mx plus b, it is logical. We can agree with me that we can literally, it means that it's possible to transform a standard form into a slope-intercept form. So now let's consider this example. So an example, this is a random example popping out of my head. So if I say something like 3x plus 3y, oh, that's kind of too obvious. How about 2y plus 1 equals 0? So how can we graph this? Well, first you have to put this in, but this first step first, you have to change this into, you want this form. You want this form y equal mx plus b. This is easier to graph when you have this form y equal mx plus b. So basically, you have to just solve for y. By solving for y, just keep 2y here, and then this is negative 3x minus 1. Now I want to solve for y, divide both sides by 2. By 2. By dividing both sides, dividing each term by 2. So this is negative 3 over 2 x minus 1 over 2. Once you have this, and then you're ready to graph. But before you do anything else, first compare to identify what your m is and what your b is. So compare with y is equal to, let me write this properly, compare with y equal mx plus b. Once you compare, you can see that your m is negative 3 over 2, and your b is that. So your m is negative 3 over 2, your b is negative 1 over 2. So you see now we have fractions just like I said in the last video, it does not matter what the number is. It's always going to be divisible. So your b in this case is negative a half. Negative a half is right in between here. That's your negative a half. And your rise, because you know that m is equal to negative 3 over 2, this is equal to rise over run. Your rise is negative 3. Because it's negative, but going down by 3. So We go 1, 1, 2, 3, and then we are running 2. 1, 2. So that's the dot over there, and you repeat the same thing. 1, 2, 3, and then 1, 2, 1, 2, right there. So when you're done with that, like I always say, 3 points is enough. You don't have to go too much. 3 points is enough to know how the line looks like. And then you just connect it. So this is your graph of y is equal to, or rather, I put it in the original form of the equation. It is 3x plus 2y plus 1 equals 0. So that's it for this particular example. So now the official part 4 of lesson number 1 begins from here. So when we're doing the exact same thing, but now we're doing it for 2 equations. Because of time, I will do only one example for this one. So let's consider an example with part F. So if you're given 2 equations, y, so what is given is y is equal to 5 minus 3x, and y is equal to 2x minus 5. We can call this your line 1, and then call it line 2. Now, it's very important to differentiate these two. Your line 1 is y equal 5 minus 3x. And we can rewrite this to become y equal negative 3x. You're just bringing it forward. You're not bringing over the equal sign. So the sign stays the same. So negative 3x plus 5. That's for line 1. And then when you compare with y equal mx plus b. Once you compare, you see that m is negative 3, your b is 5. So clearly your m is negative 3, b is 5. And then your line 2, y equal 2x minus 5. And then once again you compare with y equal mx plus b. Once you compare, once again your m is you can see what your m is clearly. There's no way you can miss that. So your m in this case is 2, b is negative 5. And that's almost part of what you need. And then that's everything you need. And then you need a graph and you're finished. It's as simple as that. Okay, so now we go ahead and do line 1. Line 1, the slope of line 1 of, let's start with the b, which is the y-intercept. The y-intercept of line 1 is 5. So 1, 2, 3, 4, 5. Here is your 5. From this 5, the slope is negative 3. So which means that, well, if slope is negative 3, it means that the rise is negative 3, and the run is 1. I know it's contradictory when we say rise is negative 3, because negative is supposed to be down. So we're not rising, technically, we're rising down, we're not rising up. Rise means something rising up, but in this case, because it's negative, we're going down. So we have to count down by negative 3 and then run 1. So 1, 2, 3, and then run 1, 1. 1 here. And then repeat again, 1, 2, 3, and then run 1, 1. And there you have it. So you just go ahead and connect these 3 dots, and you're finished. Because these are lines, I'll go ahead and call this line 1, because that's what I have defined the equation to be. I call that line 1. So let's go ahead and do line 2. Line 2, your slope here is -5. So go ahead and count 1, 2, 3, 4, 5. Here's the -5. You make your dot. This is -5. And your rise, your slope here is 2 over 1, which is rise over run. Means that your rise is 2 and your run is 1. So from there, you go ahead and rise up by 2, 1, 2, and then run 1. Do that again. So run 1. Make a dot. Repeat again. 1, 2, and then run 1, 1. Right there. And then you go ahead and intersect that dot over there. So you can clearly see at this point over here. So we'll call this line 2. And it's very clear that this dot is the point of intersection, because that is where both lines intersect each other. So therefore, the point of intersection for that, the point over there, this is 2, and this is -1. So as a point, remember we'll call the x coordinate first before the y coordinate. So this is call the x first before y. So this is 2, -1. So I'm saying x, y. So you need to know how to write a point first. If you don't know how to write a point, please go back to my first video, which is on lesson number 1, part number 1. Is just mainly about, part of it is just about defining the point. So a point is x, y. So this is it. So I hope this is clear. I'm going to zoom out. You as the student, I'm going to have you pause the video, okay? And try to do any of the problem like part A, B, C, D, E. Use this exact same step and you will be fine, okay? So do it yourself. You learn by doing. If you try to do this yourself, okay? So let me know if you have questions. Leave a comment in the comment section. I'll do my best to respond as soon as possible. All right, so that'll be the end of lesson number 1. Lesson number 2 will begin hopefully by Friday. I'll do my best because I'm doing 2 subjects at the same time. We'll do my best to come back to grade 10 again and go back to the other one. All right, so I'll see you guys. I'll upload another video. You watch it whenever you can and do the work. So that'll be it for today. We'll sign out now. Bye. Thanks for watching. Bye-bye.